Hello, we bring to you yet another very nice puzzle, very representative of the LR sets that CAT asks. By representative, I mean decently scary. You don't get a very obvious start. You think there are too many things playing around here, you don't know what to do. But if you persist and you are able to crack the beginning of it, then things can follow into a logical flow, and after seeing the solution you should or you would think that, hey, it was not at all difficult. So it could very easily be made into an LR set with 3-4 questions to it. So do give it a good try. By good try, I mean if you don't get it in your first attempt, leave it, don't watch the solution, try it at least one more time. Only when you finally give up, then continue with the solution. So I'm assuming that you're going to follow that, and I'll go ahead with the solution now. So we have Amar, Akbar, Anthony going to the gym. There's in no order. One of them goes every second day. And while in the original one, I had explained clearly that every second day means with a gap of 1 day between 2 consecutive visits. This will not be actually explained in so much details. Every second day is a very standard notation. Okay. Goes every third day is a very standard notation. Every third day means after a gap of 2 days, every third day, that is, right? And so on. And the third one goes every 7th day. And now they visit the gym in the above fashion on a regular basis since years without missing any day. Okay, so this point is also decently important. Now in a particular month, we don't know which month that is, Amar went to the gym for the first time on a Monday. Akbar went to the gym for the first time on a Wednesday, and Anthony went the first time on a Friday. And the question is asking us on which date did all 3 visit the gym, and I have added this condition that yes, they did visit the gym. All 3 of them did visit the gym on the same day. Which day was that? And then you could have other questions like at who goes at which frequency, who is the one who goes every third day, who went, what day is the first visit, and so on. So the idea over here is this, students: every second day, every third day. Where is this? Every third day. So the focus here has to be the date of first visit. If I focus on this, and this is like, it's straight in front of us, but we don't see it as much. The one who goes on every second day, the date of his first visit has to be the first of the month or the second of the month. If he has to go every 2 days, every second day, he goes on 1st, 3rd, 5th, 7th, or he goes on 2nd, 4th, 6th, 8th. His first visit will be either 1 or 2. Every 2 days, take a span of 2 days, 1 visit has to be there in that. So I take the first 2 days of the month and he has to visit the gym once there. Very simple, students. Yeah. Let's see if you can manage this for the second one. So if someone is visiting every third day, this comes from multiples. If I say every 5th number is a multiple of 5 consecutive numbers, there has to be a multiple of 5 in it. Take any 5 consecutive numbers, and that 5 has nothing to do, that same idea. So take 3 days, every third day goes. So between 1, 2 and 3, take any 3 consecutive days, there has to be 1 day that he would be visiting there. So the first visit, so the focus is on this first visit, students. And this is what, practicing LR puzzles or so on tell. They give you an idea of how to find the weakest link of how to unravel the set. So the date of the first visit of this guy will either be the first or the second or third. And similarly, the one who visits every 7th day. Now, as the frequency increases, the possibility also increases. It could be anything from the 1st to the 7th. 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. But his first visit will be between this. Okay. And this first visit is given to us that one of it is on a Monday, one of it is on a Wednesday, and one of it is on a Friday. So they are not on the same day. Had they all three visited on the 1st of the month, then all the first visits would have been the same weekday. But there are 3 different weekdays. So the days here, the date that we are looking at now for the 3 people are 3 different days. It's not the same date, right? And not just any 3, they are Monday, Wednesday, and Friday. But we don't know who is the first one, who is the second, who is the third. So what I can just do is, Monday, Wednesday, Friday, the weekdays, they move in a cycle. So take help of a cycle, take help of a circle. Now you don't know where, but somewhere there is a Monday in this. Okay, let's go clockwise. And then there is a Wednesday. Excuse me. Sorry. And then there is a Friday. And they'll keep repeating. Now, why I put it in a circle like this is you don't know which is the this first or second, which is it? Is it a Monday? Is it a Friday? Is it a Wednesday? We do not know. Okay, so 3 different days. These 3 different days are present in this amongst these dates. And now what you realize is the difference between a Monday and a Wednesday is 2 days. Between a Wednesday and Friday is 2 days. And between a Friday and a Monday is 3 days. Saturday, Sunday, Monday. So I need 3 dates. 1 out of these, 1 out of these, and 1 out of this, such that the difference between them is 2, 3, 2 in some order. So if I start from this list, because this is a smaller list, go ahead, think on your own, students. Now it will suddenly unravel that. If he visits on the 1st, then another person should visit either 2 days after that or 3 days after that. So the next person cannot visit on the same 1st, because then the weekdays would be same. He cannot visit on 2nd. Why? Because if someone visits on the 1st and another person visits on the 2nd, then they're going on consecutive days. Then the days over here could not be Monday, Wednesday, Friday. There needs to be 2 consecutive days. 1st and 3rd, possible. How about 2nd and 1st? If he visits on 2nd and this guy visits on 1st, they are again consecutive days. He is visiting 1st, he is visiting 2nd on consecutive days. But the first visits are not on consecutive days. So it can't be 2nd and 1st. It can't be 2nd and 2nd. They would have the same day. It can't be 2nd and 3rd, because 2nd and 3rd will again be consecutive days. So if you just look over here, this much is enough for us to realize that the guy who visits on the 2nd day will visit on the 1st of the month. And the guy who visits every 3rd day will visit on the 3rd of the month. That's it. And we have got it. The set is unraveled. Just needed this much of a thought, that the difference between Monday, Wednesday, Friday are a gap of 2 or 3 days, and every 2nd day means either 1 or 2, every 3rd day means 1, 2 or 3. So choose 2 days out over here which have a gap of 2 or 3 days. That's it. So the guy who visits on the 2nd day visits on the 1st of the month. Now this 1st of the month, what was it? We do not know. It could be anything. So could it be a Wednesday? The 1st could be a Wednesday. Then the 3rd will be a Friday. Okay, a 2-day gap possible. Could the first be a Friday? If the first is a Friday, then the third will become Saturday, Sunday. But Sunday no one is visiting. So this first one cannot be the Friday. If this is a Friday, this will be a Sunday, but then no one is visiting on a Sunday. And if this is a Monday, first is a Monday, then the third will be a Wednesday. And is there someone visiting? Yes. So the first could either be a Monday or could be a Wednesday, but it can't be a Friday. So 2 cases are there. Make 2 cases and that's it. Whenever you get 2 cases, I would obviously make the first case is going to be first is a Monday and the second case is first is going to be a Wednesday. These are the 2 cases. So let's continue. Let's wind up. So first is a Monday. So this person is visiting on the first, every second day, third, fifth, seventh, every odd days. His first visit is on the first, which is a Monday. And since first is a Monday, who is this guy who visits on a Monday? Amar visits on a Monday. About this guy who is visiting every third day, he's going to visit the first time on the third and every third day. 3, 6, is it on the screen? Yes. 9, 12. And his first visit was on third, which is a Wednesday. Monday, Tuesday, Wednesday. And who goes on a Wednesday? Akbar goes. So the second person is Akbar. So if we have found out for the 2 guys, then obviously we know for the third guy. So now the third guy is a conclusion. Okay. The third guy has to be Anthony. Okay. And he has to be the one who visited on a Friday. Okay, and if he is the one who visited on Friday, third is this, fifth is the Friday. So the visits of his, so pay attention, from here we are coming to these dates now because we have not found for this guy. His visits are 5 on the 5th, 5 plus 7, 12. Now look here, 5. On 5th he visited along with Amar, but 5 is not over here. On 12th he visited along with Akbar, but 12 is not over here. 12 plus 7, that's a 19. 19 Amar will be there because it's odd, but 19 Akbar won't be there. It's not a multiple of 3. And 19 plus 7 is a 26. Now on a 26, neither will Amar be there nor will Akbar be there because it's not a multiple of 3. And this ends, the month ends. If you add 7 to it, it goes beyond the month. So if you look over here, you find there is no common date for all 3. There is no common date for all 3. So this case seems unlikely because it's given that they did visit all 3 together. So this is not going to be the case. So this has to be the case. Let's finish it the same way. The first person, he visits on 1, 3, 5, 7 every odd day. The first this time is a Wednesday. And who visits on a Wednesday? On a Wednesday, Akbar went to the gym. So this first guy is Akbar. So Akbar is the one who is visiting every second day. Okay, then this guy who visits on third, he visits on the 3rd, on the 6th, on the 9th, every multiple of 3. Okay, and the third this time is a Friday. If first is a Wednesday, third will be a Friday. And who is going on a Friday? Anthony is going on a Friday. And so now we can deduce about the third one, which is Amar. Okay, and Amar will be the one who goes on the only other day left out, Monday. So if third is a Friday, 4th, 5th, Saturday, Sunday, 6th is a Monday. So his date that he goes, the first time that he goes is 6th. And from here you can find all the days that he visits. He visits on the 6th, Simultaneously try to find the common. 6 is even, so won't be here, but along with Anthony. 6 and 7 is a 13. 13 will be along with Akbar, but Anthony won't be there, not a multiple of 3. 3 and 13 and 7, 20. Now 20 is neither odd nor a multiple of 3, so 20th Amar alone would be going over there. 20 plus 7, 27, and that's the end of the month, because you can't add 7 more, it will go beyond. But if you look at 27, 27 is a multiple of 3 also, so it will be present in this list also, and 27 is odd, will be present in this list also. So the only common date for all three in this case is date is 27th. So which is the date of this where they all three went? Was 27th. Who goes at what frequency? Akbar goes every 2 days, Anthony goes every 3 days, Amar goes every 7 days. Who visit was on Monday, Wednesday, Friday? Akbar was on Wednesday. First visit on a Monday. All things got done. All by just thinking about every second day means 1 and 2, every third day means 1, 2 and 3, and picking 2 dates such that they have a difference of 2 or 3 days. That's it.